volcanoes. These fiery mountains evoke awe and fear. They remind us of the immense power that lies beneath our feet. For millennia, they have shaped our planet. They have created land masses and sculpted landscapes. Volcanoes are a testament to the dynamic forces that govern Earth. Volcanic eruptions are spectacular events capable of both creation and destruction. Molten rock, ash, and gases erupt from deep within the Earth. These eruptions can reshape landscapes in a matter of hours, burying entire cities under a blanket of ash. But volcanoes are not simply agents of destruction. They are also sources of life. Volcanic soils are incredibly fertile, rich in nutrients that support a diverse array of plant life. Over millions of years, the action of volcanoes has shaped our atmosphere and oceans. Volcanoes have played a crucial role in making Earth the habitable planet we know today. Volcanoes are found all over the world. They occur at the boundaries of tectonic plates. These plates are constantly shifting and colliding. This movement creates pressure and heat. The pressure and heat melt rock deep within the Earth. This molten rock is called magma. When magma rises to the surface, it erupts as lava. Lava flows can be slow-moving or incredibly fast, traveling for miles and destroying everything in their path. Volcanic eruptions also release massive amounts of ash and gases into the atmosphere. Ash can travel thousands of miles, disrupting air travel and affecting climate patterns. Volcanic gases can be toxic, posing a serious threat to human and animal life. Despite their destructive potential, volcanoes are an integral part of our planet's ecosystem. They are a constant reminder of the powerful forces that shape our world. Volcanic activity is a sign that our planet is alive. It is a reminder that the Earth is constantly changing and evolving. These changes occur over vast stretches of time, and we often fail to grasp their significance. For many cultures, volcanoes hold a special place in mythology and folklore. They are often seen as both deities and demons, objects of reverence and fear. These beliefs reflect the power and unpredictability of volcanic eruptions. Volcanoes can have a profound impact on human societies. They can displace communities and disrupt economies. But they can also create new opportunities. Volcanic landscapes often attract tourists, offering breathtaking views and unique geological formations. Understanding volcanoes is essential for mitigating their risks and harnessing their benefits. Scientists study volcanoes to predict eruptions and to understand the Earth's interior. Volcanic eruptions can have a devastating impact on the environment. They can destroy entire ecosystems, trigger wildfires, and pollute water sources. The immediate aftermath of an eruption can be a scene of utter devastation. However, life has an incredible ability to adapt and recover. Even in the harshest volcanic landscapes, life finds a way. Certain plant and animal species have evolved to thrive in these challenging environments. Volcanic eruptions can also create new habitats. Lava flows can solidify into new land masses, and ash deposits can create fertile soil for new plant growth. Over time, these newly formed habitats can support a surprising diversity of life. The relationship between volcanoes and the environment is complex and multifaceted.
Animals have an uncanny ability to sense changes in their environment. They are finely tuned to subtle cues that humans often miss.
Long before an eruption, volcanoes provide warning signs. The ground may swell, gases may seep from the earth, there may be an increase in seismic activity.
Animals are quick to pick up on these subtle changes. Birds may change their flight patterns. Mammals may move to higher ground. Fish may behave erratically.
These behavioral changes are often the first indication that something is amiss. Scientists are increasingly studying animal behavior to improve volcano monitoring and prediction.
By observing animal behavior, scientists can gain valuable insights into the early warning signs of an impending eruption. Understanding how animals react to volcanic activity is crucial for both human and animal safety.
Volcanic eruptions are a powerful reminder of the forces of nature. They can be terrifying and destructive, but they are also a testament to the resilience of life. Even in the face of such devastation, life finds a way to adapt and recover. In the aftermath of an eruption, the landscape may appear barren and lifeless, but beneath the surface, life is already beginning to return. Seeds buried in the ash begin to sprout. Insects and other small creatures emerge from their hiding places. Over time, the ecosystem will begin to recover. Plants will colonize the newly formed soil. Animals will return to the area, drawn by the promise of food and shelter. The process of recovery can take years, decades, or even centuries. The story of volcanoes and animal behavior is a story of survival, adaptation, and the enduring power of nature. It is a story that highlights the interconnectedness of all living things. Volcanic eruptions are not all the same. They vary in intensity, duration, and the type of materials ejected.
Some eruptions are explosive. They send plumes of ash and gas high into the atmosphere. Others are effusive. They produce slow-moving lava flows. The type of eruption depends on several factors. These include the composition of the magma, the temperature, and the amount of gas trapped within it.
The viscosity of the magma plays a crucial role. It determines how easily gas can escape.
Explosive eruptions are the most dramatic and destructive. They are often associated with stratovolcanos. These are steep-sided cones built up over time by layers of lava and ash. The magma in these volcanoes is typically viscous and gas-rich.
When pressure builds up beneath the surface, it can lead to a cataclysmic release of energy. Ash, rock fragments, and hot gases are ejected with tremendous force. These eruptions can pose a significant threat to life and property. Section 2, a cascade of chaos. The immediate effects of a volcanic eruption can be devastating. Pyroclastic flows, one of the most dangerous hazards, are fast-moving avalanches of hot gas, ash, and rock fragments. They can travel at speeds of up to 400 miles per hour. These scorching currents incinerate everything in their path. Pyroclastic flows were responsible for the destruction of Pompeii and Herculaneum. These Roman cities were buried by the eruption of Mount Vesuvius in 79 AD. Lahar's another significant hazard are mud flows composed of volcanic debris and water. They can be triggered by heavy rainfall or the melting of snow and ice on the volcano's slopes. Lahars can travel for miles, burying valleys and destroying infrastructure. Volcanic eruptions also release a cocktail of toxic gases. These include sulfur dioxide, carbon dioxide, and hydrogen sulfide. These gases can cause respiratory problems, acid rain, and even death. Section 3. When mountains explode. The explosive power of a volcanic eruption is measured using the Volcanic Explosivity Index, or VEI. The VEI scale ranges from 0 to 8. Each number represents an increase in explosivity of about tenfold. Eruptions with a VEI of 0 to 2 are considered effusive or mildly explosive. They are relatively common and typically pose little threat to human life. Eruptions with a VEI of 3 or 4 are more explosive. They can cause significant damage. The 1980 eruption of Mount St. Helens was a VEI 5 event. It ejected a cubic mile of material and caused widespread devastation. Eruptions with a VEI of 6 or higher are rare but incredibly powerful. They can have global impacts. The 1883 eruption of Krakatoa in Indonesia had a VEI of 6. It triggered tsunamis that killed tens of thousands of people. The eruption also injected so much ash into the atmosphere that it caused global temperatures to drop. Section 4. Silent but deadly. While explosive eruptions capture headlines, effusive eruptions can also pose significant hazards. Lava flows, though slow-moving, are relentless. They can engulf homes, roads, and entire communities. The 2018 eruption of Kilauea in Hawaii produced massive lava flows that destroyed hundreds of homes. The eruption lasted for months. It dramatically reshaped the landscape. Effusive eruptions can also release large amounts of sulfur dioxide. This gas can react with water vapor in the atmosphere to create volcanic smog, also known as VOG. VOG can cause respiratory problems, especially for people with asthma. In addition to lava flows and VOG, effusive eruptions can also trigger earthquakes and landslides. These events can further exacerbate the damage caused by the eruption. Section 5. Flows of fire. Lava flows are mesmerizing and terrifying in equal measure. Molten rock, heated to thousands of degrees Fahrenheit, oozes from the earth. It flows downhill, consuming everything in its path. The speed and viscosity of a lava flow depend on the composition of the magma. Basaltic lava, which is low in silica, is relatively fluid and can flow quickly. Andesitic and rhyolitic lavas, which are richer in silica, are more viscous and flow more slowly. These flows can form lava domes, which are mounds of solidified lava that can grow to be quite large. Lava flows rarely pose a direct threat to human life. People can usually outrun them. However, they can cause significant property damage. Lava flows can incinerate forests, bury homes, and cut off escape routes. The intense heat from a lava flow can also ignite wildfires, adding to the devastation. Section 6. Suffocating clouds. Volcanic eruptions release a deadly cocktail of gases. These gases can be invisible, they can be odorless, but they are no less lethal. Carbon dioxide, a colorless and odorless gas, can be particularly dangerous. It is heavier than air and can accumulate in low-lying areas. High concentrations of carbon dioxide can displace oxygen, leading to asphyxiation. Sulfur dioxide, another major volcanic gas, is a pungent, irritating gas that can cause respiratory problems. It can also react with water vapor in the atmosphere to create sulfuric acid, which falls to the ground as acid rain. Acid rain can damage crops, contaminate water supplies, and corrode buildings. Hydrogen sulfide, another volcanic gas, is highly toxic even in small concentrations. It has a characteristic rotten egg odor. Exposure to hydrogen sulfide can cause headaches, nausea, and even death. Section 7. A world transformed. The immediate effects of a volcanic eruption are dramatic and devastating, but the long-term impacts can be just as profound. Volcanic eruptions can alter the global climate. Large eruptions can inject massive amounts of ash and gases into the stratosphere. This material can block sunlight, leading to a cooling effect on the Earth's surface. The 1815 eruption of Mount Tambora in Indonesia caused the year without a summer. Global temperatures dropped, resulting in widespread crop failures and famine. Volcanic eruptions can also contribute to the greenhouse effect. They release carbon dioxide, a greenhouse gas, into the atmosphere. However, the amount of carbon dioxide released by volcanoes is dwarfed by human emissions from fossil fuels. Over geologic time, volcanic eruptions have played a crucial role in shaping Earth's atmosphere and oceans. Section 8. The aftermath. In the aftermath of a volcanic eruption, the landscape may appear barren and lifeless. But beneath the surface, the forces of renewal are already at work. Volcanic soils, though initially sterile, are rich in nutrients. Over time, these nutrients are broken down and made available to plants. Pioneer species such as lichens and mosses are the first to colonize the ash-covered ground. These hardy organisms help to break down the rock and create soil. As the ecosystem recovers, more complex plants and animals begin to return. Insects are drawn to the newly vegetated areas. Birds follow, feeding on the insects and dispersing seeds. The process of recovery can take years, decades, or even centuries, depending on the severity of the eruption and the resilience of the ecosystem. Section 1. The Sixth Sense. Animals often seem to possess an uncanny ability to sense danger. They can detect subtle changes in their environment that humans often miss. This sixth sense is particularly evident in the way animals respond to impending natural disasters. Volcanic eruptions are a case in point. Long before the ground begins to tremble or the air fills with ash, animals often exhibit behavioral changes that suggest they are aware of the impending danger. These changes can range from subtle shifts in activity patterns to mass exoduses from affected areas. Scientists are still trying to understand how animals detect the warning signs of an eruption. Some believe that animals can sense changes in air pressure, gas emissions, or even subtle tremors that precede an eruption. Others speculate that animals may rely on infrasound, low-frequency sound waves that humans cannot hear. Whatever the mechanism, there is no doubt that animals are remarkably adept at sensing changes in their environment that signal an approaching volcanic eruption. Section 2, subtle shifts and tremors. An increase in seismic activity is an early sign of a volcanic eruption. Magma rising causes the ground to swell and crack, generating small earthquakes. Animals are highly sensitive to vibrations, often detecting tremors humans can't. Birds have specialized organs to detect faint tremors. This sensitivity makes them attuned to seismic activity before eruptions. Subtle shifts and tremors may prompt animals to move to safer ground. Section 3, a change in the air. Volcanoes release gases like sulfur dioxide and carbon dioxide before an eruption.
These gases can have a distinct smell, detectable by some animals. Birds, in particular, avoid areas with volcanic gases.
Changes in air composition affect animal behavior. High carbon dioxide levels can make animals lethargic or disoriented. This is seen near volcanic vents with high carbon dioxide.
Volcanoes also release heat into the environment. Animals detect this heat through air temperature changes or infrared radiation. Some snakes have heat-sensing organs sensitive to environmental heat changes.
Section 4, whispers of the Earth. Infrasound sound waves with frequencies below the range of human hearing is another potential way animals may sense impending volcanic eruptions. Volcanic activity can generate infrasound waves that travel long distances through the ground and air. Elephants, as mentioned earlier, are known to communicate using infrasound, and there is evidence that they may be able to detect infrasound from volcanic activity. Other animals, such as whales, giraffes, and even some insects, are also known to use or be sensitive to infrasound. While more research is needed to understand the role of infrasound in animal perception of volcanic activity, it is plausible that these low-frequency sound waves could serve as early warning signals, allowing animals to sense danger from afar. Section 5, early warning systems. The sensitivity of animals to subtle environmental changes associated with volcanic activity has not gone unnoticed by scientists. In recent years, there has been growing interest in using animal behavior as an early warning system for volcanic eruptions. By monitoring the movements, vocalizations, and other behaviors of animals living near volcanoes, researchers hope to gain valuable insights into the early stages of volcanic unrest. This information could then be used to improve eruption forecasting and help protect human lives. For example, in Nicaragua, scientists have successfully used the behavior of cattle to predict eruptions at the Tectonic volcano. The cattle, which graze on the slopes of the volcano, become agitated and flee to lower ground hours before an eruption. While animal behavior alone cannot predict volcanic eruptions with certainty, it can provide valuable clues that, when combined with other monitoring data, can help improve our understanding of these powerful natural events. When faced with the imminent threat of a volcanic eruption, animals exhibit a range of responses, much like humans do. Some animals flee from danger, seeking refuge in safer areas. Others may exhibit fight or flight responses, becoming agitated or aggressive. Still, others may freeze in place, hoping to avoid detection. The specific response an animal exhibits likely depends on a variety of factors, including the species' age, sex, and previous experience with volcanic activity. For example, larger animals with greater mobility, such as elephants or deer, may be more likely to flee an area, while smaller animals, such as rodents or insects, may seek shelter underground. Animals that rely on camouflage or have limited escape options may be more likely to freeze in place, hoping to avoid detection by predators or the worst of the eruption's effects. For many animals, the most intuitive response to an impending volcanic eruption is to move to higher ground. This behavior is particularly common in animals living on the slopes of volcanoes, where lava flows, pyroclastic flows, and lahars pose the greatest threat. Birds, with their ability to fly, have a clear advantage in such situations, and they are often observed fleeing affected areas well in advance of an eruption. Mammals, too, can move quickly over land, and many species, such as deer, elk, and monkeys, are known to migrate to higher elevations in response to volcanic activity. Even insects and other invertebrates may exhibit this behavior, climbing trees or seeking refuge on higher ground to escape the suffocating ash and gases released during an eruption. While seeking higher ground is a viable option for some animals, others find refuge underground. Burrowing animals such as rodents, snakes, and some insects are particularly well suited to this strategy. Underground burrows provide protection from the intense heat, ash, and gases released during an eruption. The temperature below ground remains relatively stable, even during extreme weather events, and the soil itself can act as a filter, removing some harmful gases from the air. For animals that rely on burrows for shelter and reproduction, the ability to retreat underground during a volcanic eruption can be the difference between life and death. Section 9. Nature's alarm bells. The behavior of animals in the face of natural disasters like volcanic eruptions is a testament to their remarkable ability to sense and respond to changes in their environment. The subtle cues that animals detect, whether it's a change in air pressure, a faint tremor, or the distant rumble of infrasound, serve as nature's alarm bells, warning them of impending danger. By paying attention to these alarm bells, we can learn valuable lessons about the interconnectedness of all living things and the importance of respecting the delicate balance of nature. The sixth sense of animals may hold the key to improving our own ability to predict and prepare for natural disasters, ultimately helping to protect both human and animal lives. Section 1. Survival in the shadow of fire. Volcanoes, with their fiery displays of Earth's power, might seem like landscapes of utter destruction, yet life persists, even in these extreme environments. Animals, over millennia, have developed remarkable strategies to cope with the challenges posed by volcanic activity. These adaptations are not merely acts of chance, but testaments to the power of natural selection. In the shadow of volcanoes, survival hinges on a delicate balance. Animals must be able to sense impending danger, react quickly to escape immediate threats, and adapt to the altered landscape left in the wake of an eruption. Some species have evolved to tolerate the harsh conditions, while others have developed avoidance strategies that are nothing short of astonishing. The study of these survival mechanisms provides a glimpse into the resilience of life and the remarkable ways in which animals interact with their ever-changing environment. It highlights the intricate dance between destruction and renewal that characterizes volcanic landscapes. Section 2. Adapting to a world of extremes. Living near active volcanoes requires a unique set of adaptations. The challenges are many. Temperatures can fluctuate wildly. The air can be thick with noxious gases and fine ash. Food and water sources can become scarce or contaminated. Animals that thrive in these volatile environments possess physical and behavioral traits that allow them to withstand these harsh conditions. Some have developed specialized respiratory systems to filter out volcanic ash. Others have thick skin or scales to protect them from the heat and abrasive ash. Behavioral adaptations are equally crucial. Many animals have altered their feeding habits, becoming opportunistic scavengers in the aftermath of an eruption. Others have shifted their ranges, moving to higher ground or seeking refuge in caves or burrows. The ability to adapt to change with the rhythm of the volcano is key to survival. Section 3. The Dance of Avoidance. The most effective way to survive a volcanic eruption is to avoid it altogether. Many animals have developed an uncanny ability to sense the warning signs of an impending eruption and move to safer ground. This sixth sense is a combination of acute sensory perception and learned behavior passed down through generations. Birds, with their keen eyesight and ability to cover vast distances, are often the first to flee an area. Mammals, too, pick up on subtle cues like ground tremors, changes in air quality, and infrasound, prompting them to seek higher ground or move away from the volcano's flanks. Even insects and other invertebrates exhibit avoidance behavior. Ants have been observed moving their colonies to higher ground days before an eruption. Earthworms sensitive to ground vibrations will burrow deeper or flee to the surface, a behavior that has long been recognized as a potential predictor of seismic events. Section 4. The Shelter Seekers. For creatures that cannot outrun the fury of an eruption, seeking shelter becomes paramount. The type of shelter varies depending on the animal and the nature of the threat. Burrowing animals, such as rodents, reptiles, and amphibians, find refuge underground where temperatures are more stable, and the soil provides some protection from ash and gases. Caves, crevices, and hollow logs offer shelter for larger animals like bears, big cats, and ungulates. These natural shelters provide protection from the elements and a safe haven from the immediate dangers of the eruption. Aquatic animals face different challenges. Fish in lakes and streams near a volcano may experience changes in water temperature and oxygen levels due to ash fall or the release of volcanic gases. Some fish species are known to move to deeper, cooler water or seek refuge in underwater caves or springs. Section 5. Riding the Winds of Change. Volcanic eruptions release massive amounts of ash and debris into the atmosphere. While this ash can blanket landscapes, disrupt air travel, and pose respiratory hazards, it also creates opportunities for certain species. Spiders with their lightweight webs can capitalize on the ash fall. The ash particles provide additional structure for their webs, making them more efficient at trapping insects. This in turn leads to a greater abundance of food for the spiders. Some bird species, particularly those that feed on flying insects, also benefit from the ash plumes. The ash disrupts normal air currents, concentrating insects in certain areas and making them easier for the birds to catch. These examples highlight the adaptability of nature and the unexpected ways in which animals can exploit even the most challenging of circumstances. Section 6. Opportunists of the ashes. The aftermath of a volcanic eruption can be a scene of utter desolation, yet, even amidst the ash-covered landscape, life begins to return. Pioneer species, the first organisms to colonize a disturbed area, play a crucial role in the recovery process. Certain plants, known as fire followers, thrive in the nutrient-rich, but often sterile, soils left behind by volcanic activity. These plants, with their rapid growth and ability to fix nitrogen from the air, help to stabilize the soil and create conditions suitable for other species to establish. Insects are also quick to colonize the ash fields. Flies and beetles lay their eggs in the decaying organic matter, providing a food source for other insects and birds. Their activity helps to break down the ash and create a more hospitable environment. Section 7. The slow return. The return of animals to a volcanic landscape is a gradual process, often taking years or even decades for ecosystems to fully recover. The speed and extent of recovery depend on the severity of the eruption, the type of habitat affected, and the resilience of the plant and animal communities. Small mammals, like rodents and rabbits, are usually among the first to return, followed by larger herbivores like deer and elk, attracted by the new growth of vegetation. As the ecosystem recovers and prey becomes more abundant, predators such as foxes, coyotes, and birds of prey will follow. The recovery process is a delicate dance, a gradual reweaving of the intricate web of life. Each species plays a role, from the smallest insects to the largest mammals, in restoring balance to the ecosystem. Section 8. Life finds a way. Volcanic eruptions, while destructive, are a natural part of Earth's dynamic processes. They have shaped our planet for billions of years, creating new landforms, influencing climate patterns, and driving the evolution of life. Animals have adapted to these powerful forces, developing remarkable strategies to survive and even thrive in the face of volcanic activity. From sensing impending eruptions and seeking shelter to exploiting the altered landscape and contributing to the recovery process, animals demonstrate an incredible resilience and adaptability. The study of animal behavior in volcanic environments provides valuable insights into the interconnectedness of life on Earth and the awe-inspiring power of natural selection. Section 9, a testament to resilience. The story of animals and volcanoes is a testament to the enduring power of life. It underscores the intricate relationship between living organisms and the dynamic planet they inhabit. Volcanic eruptions, though often perceived as catastrophic events, are ultimately forces of creation and renewal. By studying how animals cope with these extreme events, we gain a deeper appreciation for the resilience of nature and the remarkable adaptations that allow life to flourish even in the most challenging of environments. The lessons learned from these volcanic landscapes can inform conservation efforts, helping us to better protect and manage ecosystems facing a variety of threats, both natural and human-induced. The survival of animals in the shadow of volcanoes serves as a beacon of hope, reminding us that even in the face of adversity, life finds a way. Section 1. Living Laboratories of Survival. Every volcanic eruption, no matter the scale, offers a glimpse into the remarkable ability of life to adapt and endure. These events, while often perceived as catastrophic, provide scientists with unique opportunities to study the interplay between animals and their environment under extreme conditions. Volcanic landscapes serve as living laboratories, allowing researchers to observe behavioral changes, track population dynamics, and unravel the mysteries of survival in the face of natural disasters. By studying these interactions, we gain a deeper understanding not only of the resilience of nature, but also of the potential impacts of volcanic activity on biodiversity and ecosystem function. The lessons learned from these living laboratories can inform conservation efforts, guiding us in our efforts to protect vulnerable species and manage ecosystems facing a variety of threats, both natural and human-induced. Mount St. Helens, a case study in resilience. The 1980 eruption of Mount St. Helens was one of the most closely studied volcanic events in history. The eruption provided scientists with an unprecedented opportunity to witness the response of plant and animal life to a major disturbance. The recovery process revealed the remarkable resilience of nature. Within months, plants began to emerge from the ash, and animals started to recolonize the area. Section 3. The return to Krakatoa. The 1883 eruption of Krakatoa, a volcanic island in Indonesia, was one of the most powerful eruptions in recorded history. The eruption, which triggered tsunamis that killed tens of thousands of people, obliterated all life on the island, leaving behind a barren wasteland. However, the story of Krakatoa is not just a story of destruction, but also one of remarkable rebirth. Within years of the eruption, life began to return to the island. Seeds carried by wind and ocean currents took root in the volcanic ash, and birds, insects, and other animals arriving from nearby islands began to recolonize the desolate landscape. Studies conducted on Krakatoa in the decades following the eruption documented the gradual reassembly of the island's ecosystem, providing valuable insights into the processes of ecological succession and the resilience of life in the face of extreme adversity. Section 4. Heime's Avian Exodus. The 1973 eruption of Eldfell on the island of Heimaey, Iceland, provided a dramatic example of the ability of birds to sense and respond to volcanic activity.
In the days leading up to the eruption, the island's large population of seabirds, including puffins, guillemots, and razorbills, began to abandon their nesting colonies. The birds, sensing the impending danger through a combination of subtle cues like ground tremors, changes in air quality, and possibly even infrasound, fled to safer ground on nearby islands or out at sea.
This mass exodus, witnessed by both scientists and residents, demonstrated the remarkable sensitivity of birds to environmental changes associated with volcanic unrest. The Jaime eruption highlights the importance of considering animal behavior in volcano monitoring and eruption forecasting, as the actions of animals can provide valuable clues about the early stages of volcanic activity. Section 5. The silent toll, unseen casualties. While much attention is often focused on the immediate and visible impacts of volcanic eruptions on wildlife, it's important to remember that many casualties may go unseen. Animals that live underground, in burrows, or in other hidden habitats may be particularly vulnerable to the effects of volcanic activity. Lava flows, pyroclastic flows, and lahars can inundate burrows and other subterranean shelters, killing or displacing their inhabitants. Ashfall can suffocate insects and other invertebrates, disrupt food webs, and contaminate water sources, leading to long-term ecological consequences. Section 6. Lessons from the ash's conservation implications. Volcanic eruptions, while a natural part of Earth's dynamic processes, can pose significant threats to biodiversity, particularly in areas where endangered or endemic species are present. The lessons learned from studying animal responses to volcanic activity can inform conservation efforts aimed at mitigating these threats. By understanding the specific vulnerabilities of different species, the types of habitats most at risk, and the potential long-term ecological consequences of eruptions, conservationists can develop more effective strategies for protecting vulnerable populations. These strategies may include establishing protected areas in safe zones, creating corridors for animal movement, and implementing habitat restoration projects in the aftermath of eruptions. The goal is to help ecosystems recover more quickly and to minimize the loss of biodiversity. Section 7. Volcanoes and wildlife. A delicate balance. Volcanoes, with their fiery displays of Earth's power, are both forces of destruction and renewal. While they can pose significant threats to wildlife, they also create new habitats, influence patterns of biodiversity, and drive the evolution of life. Understanding the complex relationship between volcanoes and wildlife is crucial for managing these dynamic landscapes in a way that balances the needs of both nature and humans. By studying animal responses to volcanic activity, we gain valuable insights into the resilience of nature and the importance of conserving biodiversity in the face of natural disasters. The lessons learned from these fiery landscapes can inform conservation efforts worldwide, helping us to protect vulnerable species and manage ecosystems facing a variety of threats, ensuring that future generations can continue to marvel at the wonders of our planet. The scars of the Earth. The landscape bears the scars of the Earth's fiery outburst. Trees stand as skeletal sentinels, stripped bare by the searing heat. The air, heavy with the scent of sulfur and ash, hangs thick and still. But nature, ever resilient, possesses an astonishing capacity for renewal. The ash, though initially suffocating, is rich in minerals that will eventually enrich the soil. Section 2. From ash to oasis, the return of life. The recovery of an ecosystem after a volcanic eruption is a gradual process, a testament to the enduring power of life. Tiny wind-borne seeds sprout tentative roots in the ash. Hardy mosses and lichens begin to colonize the ash-covered surfaces. Insects arrive, followed by birds breaking the silence. Grasses, ferns, and wildflowers paint the landscape with color. Section 3. Pioneers of a new frontier. The animals that first return to a volcanic landscape are often those with an adventurous spirit and a capacity for adaptation. Insects, with their short lifespans and high reproductive rates, are often quick to establish themselves. Birds, with their ability to fly long distances, act as both seed dispersers and indicators of the ecosystem's recovery. Small mammals, such as rodents, rabbits, and foxes, adaptable and opportunistic, find niches in the evolving landscape. Their presence attracts larger predators such as birds of prey, snakes, and in some cases larger mammals like bears or wildcats. These early colonists, the pioneers of a new frontier, play a crucial role in shaping the trajectory of the recovering ecosystem. Their grazing, burrowing, and seed dispersal activities influence plant communities and create habitats for other species. Section 4. Adapting to a transformed world. The volcanic landscape, though reborn, is not a replica of what existed before. The eruption leaves its mark on the land, altering topography, watercourses, and soil composition. Animals returning to this transformed world must adapt to these new conditions to survive and thrive. Some species may exhibit behavioral plasticity, altering their feeding habits, activity patterns, or social structures in response to the altered environment. Others may undergo genetic changes over generations, favoring traits that enhance survival in the volcanic landscape. For example, birds might develop different beak shapes for consuming new food sources, or mammals might evolve thicker fur for insulation in areas where volcanic activity has altered microclimates. This ongoing dance between adaptation and selection shapes the unique character of the recovering ecosystem. Section 5. The legacy of eruptions shaping ecosystems. Volcanic eruptions, though often perceived as destructive events, are integral to the dynamic interplay of life on Earth. Over geologic time, they have played a crucial role in shaping landscapes, influencing climate patterns, and driving the evolution of species. The periodic disturbance they create, though initially disruptive, can enhance biodiversity by creating a mosaic of habitats at different stages of recovery. Species adapted to different successional stages find niches within this mosaic, contributing to the overall richness and resilience of the ecosystem. Moreover, volcanic soils, rich in minerals, often support a greater abundance and diversity of plant life, which in turn supports a wider array of animal life. The legacy of eruptions etched into the land itself is a testament to the interconnectedness of geological processes and the evolution of life on Earth. Section 6. Volcanoes and Wildlife, a Story of Resilience. The story of volcanoes and wildlife is a story of both destruction and renewal, a testament to the enduring power of life in the face of adversity. It's a story that highlights the interconnectedness of all living things and the remarkable ability of nature to adapt and regenerate. By studying how animals respond to volcanic eruptions, we gain a deeper appreciation for the resilience of life on Earth and the intricate ways in which ecosystems recover from disturbance. These lessons are particularly relevant today, as we face the growing challenges of climate change and habitat loss. Understanding the dynamics of recovery in volcanic landscapes can provide insights into how ecosystems might respond to other forms of environmental change and can inform conservation efforts aimed at protecting biodiversity and building resilience in a rapidly changing world. Nature's fiery dance. Volcanoes, with their awe-inspiring power, have captivated human imagination for millennia. They shape our planet, creating the land we inhabit and the air we breathe. Yet volcanoes are also sources of renewal. Their outbursts pave the way for new life to emerge. We witness the remarkable resilience of nature. Creatures great and small develop strategies to cope with these fiery giants. They sense Earth's tremors and navigate by infrasound to avoid danger. These adaptations serve as a testament to the enduring power of life on Earth. Even in the face of challenges, nature finds a way. The tapestry of life around volcanoes is intricate and diverse. Each species, from microbes to mammals, plays a vital role in these ecosystems. Some thrive after eruptions, capitalizing on new resources. Others follow, contributing to ecological succession. These stories are as varied as the landscapes they inhabit. We've seen seabirds flee Haimai, seeking safety. Life returned to Mount St. Helens, anchoring the soil. Krakatoa's recovery shows nature's power to heal. These stories highlight life's adaptability and the dance between destruction and renewal. Sentinels of the Earth. The animals that inhabit volcanic regions serve as sentinels. Their behavior provides valuable insights into our planet's inner workings. By observing their movements, scientists can glean early warning signs of volcanic unrest. These animal sentinels offer a unique perspective on the forces that shape our world. Researchers are recognizing the value of integrating traditional ecological knowledge with modern science. Collaboration with indigenous communities enhances understanding of volcanic activity. This partnership improves volcano monitoring and risk mitigation. Animals in these landscapes remind us we are active participants in a dynamic world. Section 4. Volcanoes and us, a shared destiny. Volcanoes are an integral part of our planet's history and our own. They have shaped the physical landscape and human civilization. Volcanic soils support agriculture and sustain communities. Volcanic landscapes draw visitors, contributing to local economies. Yet eruptions pose significant risks to human populations. Understanding volcanoes helps us mitigate risks and build resilience. Conservation in the shadow of giants. Volcanic regions present unique challenges and opportunities for biodiversity. These harsh landscapes harbor a surprising array of life. However, they face threats like habitat loss and climate change. Conservation must consider the dynamic nature of these ecosystems. Strategies include protected areas, wildlife corridors, and habitat restoration. Prioritizing these efforts ensures the survival of unique biodiversity. Section 6. A future forged in fire. The study of animal behavior in volcanic activity shows life's resilience. These creatures adapt and thrive amidst fiery challenges, inspiring us all. They remind us that life finds a way, even amidst destruction. As we face our own environmental challenges, these lessons are urgent. Nature's adaptability and resilience must guide our actions for a sustainable future. The future, like landscapes forged by fire, will be shaped by our choices.